question like this typically shows up, but more important, we got to identify various things on a cyclohexane ring. So it says draw the chair conformer. Things have different conformations due to sigma bond rotation. So I'm going to draw two slanting parallel lines like that. And then I'm going to draw some longer lines that are also parallel, like so. Then I have these shorter lines where I connect things up like that. And there's my chair. So it says label the axial hydrogens and the equatorial hydrogens. So there's an axial hydrogen. 1, 2, 3, 4, 5, 6. Cyclohexane has 12 carbons. So this one here is always problematic. I need to practice drawing it a little better. That one's equatorial. So the next question I might like to ask, which hydrogens are facing up and which ones are facing down? If I call this like the North Pole and the South Pole, I can probably come by and say this one's pointing north, this one's pointing north, this one's pointing south, south, that one's probably pointing south. So these here, which side of the ring? This is on the southern side, this is on the northern side, this is on the northern side, this is on the southern side, northern, southern. And I know that looks like a big confusing mess. So I brought this thing in, and a conformation we didn't study is called the roadkill. The roadkill is where we flatten the cyclohexane. And when we do that, you can see this model kit is bending there, it's bending there. These that are made to be about 109 degrees are being forced to be like 120, and they don't like it. And you can see I've labeled all these groups with a white ball, so you can see they're all on one side of the ring. So if I had two methyl groups here, these were all hydrogens, this would be cis 1,2-dimethyl cyclohexane. Now let's go into the chair, and we can see that we have axial, equatorial, axial, equatorial, axial, equatorial. I hold this real nice and flat like this for the camera. Axial, 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 equatorial, equatorial. So axial, equatorial, axial, equatorial, axial. So you want to be able to distinguish these for various reasons. A good reason is this here. Name the compound below. I should have given myself more room. Well, there's the easy part. I got a cyclohexane, and I got two propyl groups. Doesn't matter on the ring where I call 1. All right, so this is a 1,4-dipropyl cyclohexane. And on the exam or quiz, if you write this down, you lose half a point. Is this cis or trans? So here's a chair. Here's this one that's an equatorial. Here's this one that's an equatorial, axial, equatorial. 1, 2, 3, 4. Imagine my hands are propyl groups. White ball, a white ball. All right, so what do you want to go with? So these are on the same side, so you want to name this cis. And hopefully you can see here. I have this axial group and this equatorial group, but they're on the same side. So this is the headrest and the footrest. Headrest, footrest. This is going up. It's an axial position. This is going out. It's an equatorial, but they're on the same face of the ring. So it's good to be able to draw this and know which ones are equatorial, which ones are axial. And then it's good to realize that these two groups are on the same face of the ring. That's why I labeled them both S. They're both facing down. These two groups, they're both on the same side of the ring. So let's go to this question here and make it look like this. I got this propyl group coming out in an equatorial position, And I got this propyl group coming out here in an axial position. And I've labeled these both pointing to the North Pole. So when they're on the same side, we call it cis. And maybe a visualization trick might be able to go like this and draw a line like that. So now what do we want to name this? It looks kind of different than that one, doesn't it? How about trans? And let's just try and relate it to this picture up top again. This propyl group here is in the equatorial position. This propyl group there is in the equatorial position. And this one's facing the top face of the ring, pointing the north or the northern hemisphere. And this one is down on the lower hemisphere. So these two are on opposite sides of the ring. So we name this one trans propyl cyclohexane. Cyclohexane ring, 2 methyls, 1, 2 dimethyl cyclohexane. So now the question is it cis? Is it trans? I'm going to go up here and I'm going to say we have a methyl group here and we have this methyl group here. So this methyl group is pointing to the down part of the ring. This one's pointing to the up part. So you still want to go with cis. I heard somebody say cis. I think we want to go with trans. Trans. Alright, so this one here, I had a model kit. We got enough time here. What do you think this is named? These are methyl groups. And they're both in equatorial positions. Is this thing cis or trans? Does this help you out? Trans. Yeah, that's trans. Alright, and let's put one in an axial position. Now they're both in axial positions. Alright, let's do the 1,4 business. If I hold the ring like this, you can see they're on opposite faces of the ring. Of course, in the axial positions, it's easy to tell. Maybe in the equatorial positions, a little harder to tell. So it's easy to look and say, well, this one's pointing this one's pointing down, and to think maybe it's not cis, but this is cis. And if we make the roadkill, there's see the model doesn't want to stay in the roadkill conformation. There you can see it's on both sides of the ring. Form a chair, and it might become a little tougher to visualize.